Welcome to the lecture 4 of Spring AI Complete course. In last lecture, we looked at working with multiple AI models. Today, we are going one level deeper into the infrastructure layer around those model calls. We are talking about Advisors API. If you have ever written a servlet filter, or a Spring Interceptor, or a Webflux filter, you already understand the concept. The difference is that this applies to every call your application makes to an LLM. So let's get into it. ChatClient is enough for demos, but not for production. Here is a situation most developer hits. You got a working chat client, prompts in, responses out. It's clean, it's simple, it works. Then your applicants becomes real. And you have few questions. How do I log prompts and responses for debugging? How do I block the prohibited content before it reaches even to the model? How do I inject metadata for observability and multi-tenant routing? How do I attach retrieval context model for RAG? And how do I address the model latency without scattering timers? You could answer all of this by adding code inside your service methods, but that turns every AI service into a chunk drawer. Business logic gets buried under infrastructure noise. The same pre-processing gets duplicated everywhere. But wait, there is a better way. So what are advisors? Advisors are a Spring AI middleware layer for LLM calls. You already understand the servlet filters or Spring MVC interceptors. You already understand the core idea here. Advisor intercept LLM calls the way filters intercept HTTP request. They sit between your application and model. On the way in, they can inspect, enrich, or block the request. On the way out, they can read, transform, or log the response. And critically, your business logic stays clean. All the infrastructure concern lives in one place. Call advisor versus stream advisors. So these are the two types of advisors which we do have. Spring AI gives you two interfaces depending on how you are calling the model. Call advisor is standard blocking call when you use .call method. Stream advisor is for streaming when you use .stream. And you are pushing tokens progressively to the UI. Same mental model, but different execution context. Now, the two objects you will work constantly are ChatClient request and ChatClient response. The request carries the prompt model options and shares the advisor context. The response carries generated tokens, uses, and the same shared context. The shared context is important. It lets one advisor pass the data forward so the another advisor downstream can read it. Advisors form a stack. This is the most important mental model in this lecture. Spend a moment here. When you attach multiple advisors to a chat client, they form a chain. Look at the request path on the screen. Request flows through the advisor A, and that's with the order of 100. Then through advisor B, an order is 200. Then it hits the model. Now look at the response path below. Response comes back from the model. Advisor B sees it first, then advisor A sees it at last. The response path is reverse of the request path. So the first advisor to the process of the request is the last advisor to the process of the response. That's the stack behavior, and that's why ordering isn't just a number. It defines the full shape of your pipeline. Get order semantics. Get order is the execution contract. Every advisor implements get order. Every advisor implements get order. Lower value means it executes earlier on the request path and later on the response path. Security and validation advisors should have high precedence. They need to see the request first. Response formatting advisors run later on the request side. They get earlier access to the response. If two advisors share the same value, execution order is undefined. So please don't leave this vague into the production. Order.highest precedence gives you the smallest integer value so that the advisor sees the request first. Make this explicit for every advisor you write. Implicit ordering causes a subtle bug that are genuinely hard to trace. So let's see a custom advisor. Let's build something real, starting with a logging advisor. Look at this structure on the screen. It implements call advisor. GetOrder returns highest precedence plus 10. We want it early, but after the security filters we will write next. The next method is advice call. First line, we log the incoming user prompt from the ChatClient request. Then chain.nextCall request. This hands the request to the next step in the chain. Everything above this line is request side logic. Everything below this is response side logic. After the chat returns, we want the model response text. Then we return the response. This is structure to log before the call chain and log after is identical to what you have written into a servlet filter or an AOP around advice. Same concepts applies to the AI. So let's write this into our working code. Now let's create the content filter advisor. Now the guardrail. GetOrder returns highest precedence. This advisor runs first before anything else touches to the request. The content filter sees it. We define a set of block term, in this case 2 phrases that should never reach to the model. In advice call, we lowercase the user text and check for any match. If a block term is found, we lock the warning and throw illegal argument exception. The exception short circuits the chain and model never gets called. If the content is clean, we call chain.nextCall request. We let it through. Today, this is the keyword block list. In real system, this blocks PII detection, regex sanitization, and tenant-specific policies and control. Prompt risk scoring. The point is, you have a clean extension point for all of it, and none of it pollutes your controller or services. Let's code this also. Now let's wire the devices together. There are 2 ways to wire it. In your configuration class, you build a chat client with default advisor and pass the content filter advisor first and then the logging filter. Because the content filter has the highest precedence, it runs first regardless of the argument order. So even if you pass it in reverse order, it will run the same way. You can do it per request and be very selective. In case if you don't want these advisors to work globally, you can use this way also. You can also attach advisor to a single call using advisors on the prompt builder. Content filter at highest precedence always runs before anything else. The execution chain flow exactly as the ordering dictates every time. So let's try to see how the both can be coded together. So this is the first way. If you see here, we have passed it directly at the bean level. So this is applicable over the entire application. So let's validate if our code works correctly. So here, I have just asked a question and let's see if our loggers are working. So you can see the prompt has been actually intercepted by logging advisor, right? And even the response also has been intercepted. So that means our advisor works exactly the way we wanted. So let's see, there is one more advisor that we have written, which is content filter, which actually blocks anything where if I want to try to have this into the text. So here you can see this has already been intercepted and it has the word password dump and it has thrown me an error. So let's go back and verify that this has happened because of our content filter advisor. So see, you directly can see that this also has happened. So one of the things that we said at the starting was the stream advisor. So let's look one of the stream advisors also. So stream advisors are for the reactive flows. If you are building a streaming endpoint, server-sent event, live chat, progressive tokens rendering at, you need a stream advisor, not the call advisor. Look at the code, same structure, but instead of ChatClient response, you return a flux of ChatClient response. Chain next stream of the request gives you the reactive stream. Do on next let you hook into each chunk as it arrives. Use this for server-sent events, live chat interfaces, and token-by-token observability. Same mental model as call advisor, just working with flux instead of the blocking response. If your application supports both call and stream path, it is probably should have different use cases for both of it. Make sure you have the right advisor for each type. They are not interchangeable. So let's code this one. So let's start the server and see if the streaming API works. You can already see that the streaming logging advisor also got invoked. So in case if you are using streams and flux, use stream advisor, otherwise you can use call advisor. So let's see the production use cases, which is the right places for cross-cutting concerns. This is where advisor starts to feel like a superpower. Once you internalize the pattern, you start seeing the cross-cutting concerns everywhere. Prompt logging for debug and compliance audit trails. Guardrails for content filter and safety environment. RAG context injection. Attach the retrieved document before the model sees the prompt. Caching. Check a result in your cache, in your advisor, and returns if it exists. Rate limiting. Throttle by user tier or a global quota before touching the model. Observability. Latency timers. Token uses metrics and micrometer hooks. Tenant metadata propagation in a multi-tenant architecture. You can also use it for response post-processing, cleanup formatting, and validation. All 8 belongs in the advisor. None of them belongs to the scattered across business logic. So let's look for the common mistakes that we should avoid. Let me call out for the mistakes I see most often. Advisor logic is in controller. Once your controllers are doing the policy checks and prompt shaping and design has already drifted, it is hard to recover from. Ignoring the order semantics, multiple advisors with no explicit order strategy produces bugs that appear in unpredictable places. One advisor for unrelated concern, logging, filter, retrieval, context, and the response shipping should be separate unit. Keep your advisor focused. forgetting stream support. If your app has both call and stream paths, you need both Call Advisor and Stream Advisor implementation. One does not cover both. So, what are the key takeaways? 6 things to walk away with. A Call Advisor for request response, Stream Advisor for streaming, not interchangeable. ChatClient request and ChatClient response carry data, shared context through the full chain. Advisors can inspect, enrich, mutate, or block, including the short-circuiting the chain entirely before the model is called. Get order controls the execution order, and the response path unwinds in reverse. Make it explicit. Attach advisors globally via the builder or selectively per request using .advisor. Custom advisors are the right home for logging, filtering, RAG, and observability. Your business logic stays clean. I want to leave you with this. A lot of tutorials focus on prompting, very few focus on architecture. But production AI systems are not defined by how cleverly you ask the model a question. They are defined by how clearly you manage everything around the question. ChatClient is how you talk to the model. Advisors are how you control the conversation pipeline. The distinction is what separates a toy integration from a production system. So in next lecture, we'll look at the tool calling, where a model stops just being the text engine. It starts invoking real Java method in your application. That is where things get genuinely interesting. If you found this useful, like, subscribe, and drop a comment below. The code is from the lecture is linked in the description. Now let's see you in lecture 5.